Hi, welcome back to PracticalStudent.com. This is part number 4 of the 2006 electronic die project. This is called the fascia plate. The motor will be mounted on the back of this and the disc on the front. The drawing itself, there are a couple of pieces of information that you'll need to find out. The hole on the drawing here is marked for 6, but it will depend on the motor you have. This is the motor I have here. And as it turns out, this section here is 6.5 millimeters, so I'm going to change that. Also, it says dimension as required for these two side screws. Now, they're absolutely tiny screws. You can see one here. Bring it up close so you can get a better look at it. So that's the screw there, very, very small. It's an M1.7 by 0.35, and it can only be I think 2.5 millimeters deep. The motor itself that I'm using, which you can get on eBay, is an RF-300C-11440, and you can get those on eBay, as I said, made by Mabuchi, but other solar motors will work. I had to search a little box of that little box of screws that everyone seems to have to find screws that were suitable. Found 4, luckily. If you can't get them, you can probably glue this on to the back of the fascia plate, but do be careful not to get glue into the screw holes. Right, so let's get on to marking this. Okay, so the piece of metal I've chosen is big enough for the actual outline of the piece, but it's not big enough for these points on the outside to find the radius or the center of this curve. So what I'm going to do at that stage is just tape the piece of metal to the table so that it can't move around, and use the table to mark it from. So this piece is already square, okay, and I'm going to use the center line up the middle here as kind of my basis for marking it out. So first of all, I want to measure my piece, and I'm getting 145 millimeters, which gives me 72.5 as halfway. Now to T-square a line up there. Now, this base piece is 140 wide, so that's 70 out from the center line. I'm going to put 70 at the center line, and then mark the end of the ruler, and 140 millimeters, and T-square lines up a short distance. Now we can measure the total height of this section is 16. So I'm going to measure up 16 here, and I'm also going to measure up 8 at the same time because my holes here are at a height of 8. So 8 and 16 on this line. And I'm going to T-square the 16 line all the way across. And I'm going to dash that. As you know, I like to dash lines that are going to be bent later on. And the 8 line I'm going to mark in distance on both sides. Now, those holes are 124 apart, so half of 124 is 62. So I'm going to put 62 on the center line, mark the end of the ruler, and mark 124. And that gives me the 2 centers for those holes, which I'm going to punch because I will be drilling 3.5 holes there. Right, the next thing we want to do is the big circle up on top. We're told it has a radius of 55 millimeters. We just need to find its centre, which we're told is 70 up from the 16 line. So that's a total of 86 from the very base. So you can mark 70 from here or 86 from here. Going to punch that as well. Now I'm going to set 55 on my dividers because that is the radius. So I'm going to start at 10 and go to 65. Which means there's 55 between the 2 points. And draw most of the circle from the centre point we just marked. That should be enough. So at this stage now I want to mark these 2 curves here. So we don't get any information about this point. All we know is that it's radius 40 for this curve. That means that from here it's 40 millimeters to there, and at this point is also 40 millimeters to this circle. So what we're effectively doing is going from here to here. That's 40, that must be 55, so we know that that radius is 95. So we can draw an arc from here, and it must be somewhere in the arc. We also know the centre is 40 from here, so if we put 40 on our dividers and draw an arc from here at 40, where they cross will be the centres for both. So first of all, I'm just going to stick down my piece onto the table. And now the piece can't move. I'm going to put 40 millimeters on my ruler or dividers. Starting at 10, I go to 50. I'm going to put my point here and draw an arc. Now you may not see, but I can see the scratch in the surface there. And I'm going to do the same on this side. You need to do a decent arc first of all to make sure that you know where you're going. And as we said, the other one is 55 plus 40, which is 95. So starting at 10, I need to go to 105 millimeters on the ruler. Centre of the circle and cut the arc, and it just barely cuts the one on this side and doesn't cut the one on this side. So I need to go back and redo my 40. So these are the 2 points here and here. And they're the centres that you see in the drawing here. So radius 40 on my dividers from those points. And I get a tangent and the location of that point. Same on the other side. And it's a tiny bit off there, but that'll be okay. When I'm filing, I'll be able to fix that. I'm going to take my piece back up again. We only have 3 holes, or 2 more holes to worry about now. And they are these 2 holes here. So I'm going to draw a horizontal line with my T-square through the centre of the big circle. And from the data sheet on the Mabuchi motor, the solar motor that I'm going to use, I found out that the pitch circle diameter for the holes, the screw holes here, is 16.5 millimeters. Now if you do want to get this data sheet yourself, just go onto Google and look up this code and you'll get that all the information about this motor. So 16.5, half of that is 8.25. So I'm going to have to try and be as accurate as I possibly can when I'm marking or setting this. This ruler doesn't have 0.5 mm markings, which would help. But we can use our eyes pretty good. Clean tips up. So that's about 8.5. So I'd say there is about 8.25. So I'm just going to mark either side of the centre, and there should be my 2 holes. Punch both of those, and we're complete with marking out. Alright, so now it's on to drilling holes. As I said earlier on, I'm going to drill a 6.5 in the middle. These 2 outer holes for the motor are going to be, the screw is M1.7, so I'm going to drill them 2, and then these 2 holes are 3.5s. There we go. So now I'm going to use the bench or the guillotine just to cut off these 2 strips here, and then I'll use the bandsaw to cut around the outline of that. So the belt sander gave me a very nice finish there. When you're doing this section here, you will want to go with a, depending on how much you have to do, a half round file, either rough or smooth, and that'll get you into this curve. Any flat file or even the other side of the half round will give you the outside of the curve. So I'm just going to tidy up these edges here and make it look all nice, get it ready for bending. So set your bending machine to 20 degrees, clamp in your piece on the bend line and bend it, and it doesn't take very much at all. And there we go. You can probably just see the bend there. You can probably just see the bend. It's not very obvious, but it will sit the piece up just that little bit straight when it's attached to the next piece. So that's part 4 done. Catch you in the next video for part 5.